So in this video tutorial we will look at matrix inverse. So far we looked at matrix addition, subtraction and multiplication, and it was pretty straightforward to do this operation with matrices. But what about matrix division? Is it so possible? Well, it's not really straightforward to do matrix division with matrices, and we have what's called the matrix inverse. So I want you to imagine that you have a number, say 5, and when we multiply this number with its inverse, or if we write it 5 to the minus 1, this will give us 1. And what we do here is that we try to get from a number, which is a matrix at our case, and get this matrix inverse, and this will give us the identity matrix when we multiply the actual matrix with the matrix inverse. So there are many ways to inverse a matrix. So I'll give you a clue about the one of them today. So you are given a matrix, say a 3 by 3 matrix, and you want to find the matrix inverse. The first thing that you have to do is to find the determinant of A. The second thing is that you have to find the cofactors, and the cofactors are taken when you find the determinant of every line and every column. So in the actual determinant, you find the determinants of the first line and the first column. When you find the cofactors, you have to find the determinants of every line and every column. You do the same thing. And then you have to inverse the signs of this matrix, and you have to inverse some numbers in the diagonals afterwards. So what we've done here is the first step. So we found the determinant, and we are going to calculate it. It's going to be 2 times 60 minus 63 5 times 10, 50, then we have 56, so 56, and then we have plus 4 times the 5 times 9, which is 45, minus 48. So we get the determinant 2 times minus 3, 2 times minus 3 minus 3 times minus 6 plus 4 minus, so this is minus 6 minus 18 minus 12, and this is 24 minus 36. So the determinant of A is minus 36. Now, as we said, we are going to find the cofactors. The second step is to find the cofactors. What to find the cofactors is that we follow the same steps to find the determinant, but we do it for every single row. So we first take the actual determinant, which is the first row with the first column. So this is going to be 6, 7, 9, 10 is the determinant that we have here. So then we have the 5, 7, 8, 10, and then we have the 5, 6, 8, 9. Then we do the same thing for the second row. The first cofactor is going to be 3, 4, 9, 10. 3, 4, 9, 10, because we hide the first column with the second row. Then we hide the second row with the second column, and we get the 2, 4, 8, 10, 2, 4, 8, 10 for the second cofactor. And then for the third one, we hide the second row with the third column, and we get the 2, 3, 8, 9. So 2, 3, 8, 9. We do the same thing for the third row and the third column. So we have 2, 3, 5, 6. No, sorry, third row, first column. So we have 3, 4, 6, 7. 3, 4, 6, 7. Then we have the third row with the second column, and we get the 2, 5, and then 3, 4, 7. 2, 4, 5, 7. And then we have the 2, 3, 5, 6. 2, 3, 5, 6. Then once we find the results of those 2 by 2 determinants, what we do is that here we have we will end up with a matrix with C1, C2, C3, C4, C5, C6, C7, C8, and C9. So these will be the matrix with your cofactors once you calculate those determinants here. And then what you do is that you put plus and minus signs in front of your cofactors. So plus, minus, plus, minus, plus, minus, plus, minus, plus. Once you do that, the next step is to inverse the diagonals except the main diagonal of the matrix. So the next step is to keep the C1, C5, and C9 as it is. C1, C5, and C9. Then C6, C8, okay, then you swap the C2 with the C4, so you're going to have C4 with C2, then you're going to have C3 here and C7 here, so it's going to be C7 with C3, and now you're going to have the C8 here with the C6, and if you keep your signs, plus, minus, plus, minus, take your determinant, which was at a equals 36. So this was our determinant. You say 1 over the debt of A, so 1 over 36, and you multiply it with this matrix here. So it's going to be 1 times C1, C4, C7, C2, C5, C8, C3, C6, and C9. And of course you keep your signs. And once you multiply the inverse of the matrix with the matrix of cofactors, then you're going to end up with A minus 1, which is the inverse of your matrix. Thank you very much.